Welcome to spss tutor 3. In this tutor we are going to focus on linear regression, particularly simple linear regression and multiple linear regression, but more emphasis is given for simple linear regression. As you see here, the contents are what's a regression model, simple regression, linear regression and multiple regression, and how the hypothesis to be tested. But in today's lesson, the hypothesis testing will not be managed. As you see, regression is a statistical approach to determine education for the straight line that best fits the specific set of data. Regression is concerned with or describing the cause-effect relationship between the y and one or more variable of the x. The y is the dependent variable and the x is the independent variable. Dependent variable can also be named as response, explained, predicted, regress, retreat, and such alike. The independent variable can also be named as explanatory, predictor, control, covariant, regressor, and such alike. As you see here in the bottom part, simple linear regression is a case where we have one just explanatory variable and the model is linear in parameter. That means there is one dependent variable, there is one independent variable. Whereas when we see multiple linear regression, we have two or more explanatory or independent variable, as mentioned above. But the model is linear in parameter as well. As you see here, regression shows a relationship between two or more variables. Mostly, this can easily be demonstrated using a scatter plot. As you see in this scatter plot, the theory suggests that an increase in x will lead to an increase in y. The scatter plots use both y and x-axis to show how two variables related to each other. If the variable almost form a straight diagonal line in a straight plot, the two variables are strongly related. Sometimes a third variable is included, adding another dimension to the plot. The corresponding variants of the scatter plot include a bubble plot or 3D scatter plot. Here, in this scatter plot, there is an approximate positive linear relationship between x and y, because, as mentioned on the top of this slide, an increase in y will lead to an increase in x. And there is an equation for it. The equation, as you see here, y is equal to alpha plus beta x. But this is not more realistic. But the most realistic equation is this one. Y equal to alpha plus beta x plus error term. These error terms can be occurred due to different reasons. Omitted explanatory variables, measurement errors, when we have committed errors in measuring, extraneous factors that cannot be modeled. This may be related to human behavior, terrorist attack, hurricane, and others, vagueness of the theory, unavailability of data, principle of parsimony or meanness can also be reasons for this extra error term. Error term is related to that of a degree of tolerance. If it is less than 0.05 or 5%, it is tolerable. If it is more than that, it is not tolerable. Here we can see with examples. Open spss advertisement data run a single linear regression in which Sales is a dependent variable because what we sell totally depend on what we do. For example, it might be the promotion that we do. For example, here advertisement spending is independent variable. So if we do good at advertisement, our sale may increase. That's why we said that sale is dependent and the advertisement spending is the independent variable. We can also interpret the coefficient and the intercept of the spss output. Here, as you see, we can first click analyze, go to regression, and there is a linear. With that we will click on it and we'll take the sales to the dependent variable box and the advertisement spending into the independent variable box. Having done that, we click OK. We get this one. The first table is about variable entered, how many variables entered, and the second is the model summary part. In this model summary part, we can have also some information, but the most common one useful is the ANOVA table. In the ANOVA table, when the sig value, that means the last row, 0.00, that is less than 0.05, we said that the variables have significant effects, or statistically significant. If it is greater than 0.05, it is not significant, statistically significant. The same is true in the coefficient variable. The last column, we can see that there are statistics that is less than 0.05. So this means that these two variables are statistically significant. That means we can reject the null hypothesis. So the intercept part 6.05 is a constant. That means no sale is done because it is at the initial part. But when we come back to this one, the advertisement spending, when we have this amount to sell, that means this implies a dollar increase with 1.075 in advertisement, sales increased by that amount. And today I think we have rushed out of time. In our fourth lesson, we will go in depth about how we interpret the space output of simple linear regression. Thank you for listening. Have a good time. Goodbye.